find something you're passionate about, focus on the problem, persevere through it. Don't be afraid to just get started. I think too often people sit and wait for the perfect time where they feel like they know enough. You have to get started.
I'm really honored by how willing you guys were to meet with us, so thank you for that.
Yeah, no problem.
Glad to be here.
We should just hop right in and just get to the questions. Could you guys give us and our audience just a quick introduction of yourselves and what you guys do?
My name is Danny Ellis. I'm the CEO and co-founder of SkySpecs.
I'm Tom Brady, also co-founder and chief technology officer of the company.
The SkySpecs mission is to simplify renewable energy asset management so that wind power can be a sustainable form of electricity in the future. We got into this business kind of accidentally. We started by building automated robotics here on campus at the University of Michigan way back in 2009, which then we built these autonomous drones up through 2012 and when we launched the business here on campus. The original idea was to have automated robotics that could look at large infrastructure in hard to reach places. We then found an application to go up to wind turbines and take pictures of turbine blades and try to assess damage. So it all started as a solution looking for a problem and the right place, right time. A lot of lessons learned early on and have since grown that business to be a complete wind energy asset management company now.
Yeah, I saw you guys have something like 200, 300 employees now, which is absolutely amazing.
Yeah, it seems like it changes every day, but yeah, about 250 team, and we're global at this point. So we have our headquarters are here in Ann Arbor. We've also acquired several companies that have allowed us to open offices in other regions. We also have offices in Hyderabad in India, in Dublin, Ireland, in Graz, Austria, in Vila, Denmark. I believe I haven't left anyone out.
Amsterdam?
No, not anymore.
No longer in
Not
Amsterdam.
anymore.
Yeah, now we operate, all of our European operations operate out of satellite spaces, both in Dublin.
That's awesome. That's really awesome. The autonomous drones. You founded the aerial vehicle. I want to get the name right.
The Michigan Autonomous Aerial Vehicles. Yeah.
It's a mouthful. You can just call it MAV. MAV for short.
It's much easier. Okay, so you founded MAV. How did your passion for drones and for aerial vehicles get started?
Yeah, I'll tell a little bit about it from my perspective, and Danny's is a slightly different journey, I suppose. So I've always been interested in aviation, in airplanes, in space, and growing up I thought that where I wanted to work was in space and extraterrestrial type aviation. All through my high school years and the early years of college, I was looking at how can you get an internship into one of these places like Northrop Grumman or any number of like Lockheed and so on. Actually, what ended up happening, so I got to school, and I don't know if a lot of people know this about Michigan engineering, but it is a lot more theoretical. There isn't a lot of sort of built-in hands-on activity to a lot of the curriculum. Essentially what ended up happening is after my freshman year, I couldn't get any of those internships I told you about. I ended up meeting Danny at an internship in Portage, Michigan, at a company called Parker Aerospace. I understand you also were unable to get those really awesome internships. Well, Parker was fantastic, don't get me wrong, but not the kind of space company I think that either of us were looking for. But it ended up teaching us a lot of things and being a great place for us to develop as engineers. So all through being at Parker Aerospace throughout the summer, I was working in a vibration laboratory where we took these rocket and airplane parts, like hydraulic systems, put them on these vibration tables, and we just shook the heck out of them really hard to see how they would behave when they're actually in action. And Danny was working in one of the engineering groups, if I'm not mistaken, so often got to come over and hang out in the test lab. And we got to get talking about our interests and how there actually was quite a bit that was aligned, and talked about the different kinds of companies we could start and a student group that we could start. Ultimately came back to Michigan the next year and started Michigan Autonomous Aerial Vehicles. And maybe that's where you want to pick up some of how that all ended up getting going.
Yeah, and so my journey is similar to Tom. We're actually from a similar hometown, very close to each other, and found out later in life that we actually played baseball against each other before we knew each other, yeah. At that same internship, we had been sitting in the test lab kind of saying, like, what are we actually going to do in life? Like, we should start a company. And we were very much joking back then, because how do you start an aerospace company? Like, we didn't think that was feasible. But when we came to campus, my journey also trying to find those internships started with a potential internship at Northrop Grumman in Southern California. I was very excited for my junior year to be going off down to somewhere warm to work on real aircraft. And this was in 2009. The financial crisis had been going on, and right before school had off for the summer, they called and said, we're going to cancel all these internships. I started scrambling to try to figure out how do I find an excuse to stay on campus for the summer. I had never done that before. I was pretty confident I didn't want to move home with my parents again for the third consecutive summer. I started calling up professors to try to just figure out, could I do some research? What am I going to have for an excuse? And I started working at the Wilson Student Team Project Center on North Campus, which is where the Formula Team, the Baja Team, Solar Car, and 40 or 50 other student teams operate. I joined that summer under strict rules that I could not join any of the student teams. I had to work as an unbiased employee for all the student teams. I've got 1 year left of school. I'm not going to have time to really contribute to these teams anyway. And through that summer, I was helping these teams with machining and fabrication and a lot of really fun hands-on things. As Tom said, at least back then, 15 years ago, the program was very theoretical. It's gotten a little bit more hands-on because technology is easier to get these days. But it's hard to work on something for an aerospace project as a student that's affordable, right? Mm-hmm. And so we were doing this. I was working this student project lab all summer with my senior design project coming up the next year. At that point, I was really excited to work on something hands-on and also felt somewhat like an imposter, where I was about to call myself an aerospace engineer, but I'd never really built anything that flew. Didn't work at any real internships that made parts that fly or any of that. That's when I proposed to the department that I wanted to build a drone for senior design. I was sitting around a bonfire at my house with Tom that summer and kind of threw out this idea that we should do this. And a few of our friends were like, no, we're graduating, we're out of here, we're not working on this. And Tom was like, let's do this, this sounds like fun. Well, he wasn't in senior design, he was in the class behind me. So I made the senior design project as kind of motivation, and then we needed money to fund the project. So we formed MAV, the student team, as a way to find funding. And we planned on doing this for a year, like at most, it was going to be a year. We found an international competition to help justify why we were doing this, and then ended up getting Northrop Grumman to fund the project. Years later, Lockheed, Boeing, a bunch of other sponsors came on board as well. The university put a lot of money into it, and it was a phenomenal way for students to learn hands-on development and programming and fabrication. And we were doing it purely for fun. It was not meant to be a business. We had not set it up in a way that we were going to try to commercialize it in any way. And then at the end of that first year, we did not finish the project. It was barely put together. It didn't even fly. It wasn't a real drone yet. And that's when we decided this needed to be a longer term project. I stayed on for my first year of grad school. The following year, Tom stayed on for another year for his first year of grad school. We continued running MAV, at which point the Center for Entrepreneurship was created. And they actually approached us and said, guys, this is a cool project. Why don't you turn it into a business? And that's when we looked at each other and we're like, we're not business students. So what does that mean? We had jobs lined up at this point to graduate and go work. And we said, you know what, let's give ourselves a year to see if this is feasible. If it's not feasible, we'll go apply for jobs then. But that's when SkySpecs was born, kind of overlapping the work we were doing at MAV. We were still finishing up grad school when we were simultaneously launching this with the help of the Center for Entrepreneurship.
One thing I want to follow up there as well on is that Michigan was really great to us in terms of a place to start our company. Some of the things that come to mind are the really supportive professors that we had that were able to pay us as graduate student instructors and allow us to also develop our business on the side. So they were super helpful throughout. In fact, one of our professors at the time now works in a part-time research capacity for our company, SkySpecs, which has been really cool to be able to have him on our team rather than as a professor 15 years ago or so now. Other things about the university that were really awesome for us, Danny mentioned the Wilson Center, now called the
Goose Family Lab,
which is just an excellent place for students to cut their teeth on really cool engineering problems. Of course, the things like the CANE, the computer network, and a really generous intellectual property policy as it relates to the U. Anything you develop here, I believe this is still the case, anything you develop here is yours to take with you, and that was a really big deal for us. But, pardon me, unless you're a doctoral student doing paid research, different story. But in our case, we were here on a different capacity. That's how it stood, and that was really important for us.
Okay, you had the project that you were working on, and then that fails, had to deal with it, and then you succeeded in another project. Could you walk through the moment that you guys got to this point where, wow, this could actually be a business that we could run and could be successful?
Well,
that
took a
while.
Yeah, I don't think there was one moment early on. In the early days, as I mentioned, we were a solution looking for a problem. And we thought bridges and infrastructure were something that would require advanced inspection. So we started calling folks at the Department of Transportation, getting meetings with them, and they all were saying, yeah, this is a great idea. And we got them to put out a call for proposals on an automated way to inspect bridges. And so we were like, all right, this is our way in. It was $150,000 of free grant money. We're going to go write this proposal, we're going to win it, and that's what we're going to build the business on. So we spent months working on this, and then we didn't win. Someone else won the proposal that was very much geared up for us. I vividly remember the day. I was teaching a lab, and Tom walked in, and he was the one that got the email that said we had lost, and we were pretty dejected, and I guess we're going to close shop and go beg for those job offers that we turned down a year prior, feeling pretty low at the time. And that's when a mentor of ours came to us and said, well, before you guys give up, there's a business competition at Ross called the Michigan Clean Energy Venture Challenge. And we were like, yeah, but we're not a clean energy company. We don't qualify. And he was one that recommended we look at wind turbines. And we literally looked at him across the table. We don't even know if they need to be inspected or what could go wrong with them. He didn't either. He was like, that doesn't matter. It qualifies you for the competition. And so we stood on stage, having never been to a wind farm, knowing nothing about the industry, put up pictures of turbines and said we're going to use drones to go inspect those. And we ended up winning first place and got about $50,000 in grant funding that we then utilized to go actually learn about the wind industry, go to conferences, meet customers. That was the first major turning point.
The moment you guys got the email, hey, you won, here's $50,000.
We didn't get the email, they told us on stage.
It was a pitch competition.
Oh,
yeah,
on stage.
Yeah, we were on stage when they told us we won and handed us a giant fake check that had $50,000 on it, and we'd never had any money in the company. That was a big deal. We weren't paying anybody, and that was a big turning point to actually spend money to go learn more.
Wow, that was a pretty big moment. After, of course, you have 12 very long years of trial, error, challenges. Can you walk us through some of the challenges that you guys face, either technical or interpersonal or whatever they may be, of taking SkySpecs and really taking it to the next level?
I would say one of the big challenges was self-inflicted, in that we had developed a certain culture and way of doing things that came from our student group. And what that meant is that we tried to do everything ourselves. That makes a lot of sense for a student group where your primary objective is to learn, whereas in a company, your primary objective is to make money. There was a lot of things that we were doing at the start that were reinventing the wheel, things that were very easy to buy off the shelf, but we felt perhaps naively that we could do it better and that we could do it faster. And it took us, I don't know, probably 2 years in that mindset before we were able to make our first pivot. And I would say that a lot of that time probably could have been avoided, and probably the money spent invested in that could have been avoided. So that was probably one of the first challenges. Again, we were very lucky to be at the university during that crucial time period, and being able to, again, leverage some of those same resources and the payment that we were getting from the university while we were getting started as the company.
Yeah, I'd say along those same lines, we didn't really understand what we were being told about developing a minimum viable product. We kept thinking, the minimum viable product is a drone. We're going to physically build a drone. And it took us a long time to realize it has nothing to do with the drone. It has to do with the data and the insights that you can give an end customer that has a problem. Once we learned that and figured that out and we focused in on real data, then that's when we started having real sales. And then the company started to take off. But it did take us a long time to get out of that student team mindset and into a real company growth mindset.
So that switch of going from this is a drone company that that flies drones versus this is a data management company for organizations to have an end result, which is working efficient wind turbines.
That was a good pitch.
About the wind turbines, could you walk us through how SkySpecs actually manages the business and does that?
Yeah, sure. So in wind energy operations and maintenance, one of the many tasks that have to be complete in order to take care of the turbine and decide what needs to be fixed is that you periodically want to look at the wind turbine blades, the three big spinning things that actually cause the thing to move. Those are not contrary to some belief, not a lifelong component. That's not something you can sort of set and forget. The reason is a number of things that you might want to look at these blades. There's damage from lightning, there's damage from rain that causes erosion, there's damage from manufacturing defects and just general wear and tear. And All of these things, if not taken care of, can lead to either a loss in production or they can lead to a loss of the whole blade. Truly, when we started in wind, I would say it was typical to inspect blades either from the ground, where you'd look up at the turbine with a telescope or a camera with a very long zoom, or in more complicated cases, we would see customers that were actually climbing the turbines, rappelling from the blades on ropes. And this was typical prior to drones coming on the scene. We came to market in 2016, 4.5 long years after we launched the company, with a product that actually solved that problem in the wind industry. And so, as you noted, it's an autonomous drone. Put the drone out in front of the turbine, you press go, and as an operator of the drone, your job is essentially to watch and make sure that nothing goes wrong, and the drone does most of the work on its own. So it takes off. It has a scanning laser rangefinder, develops a model of the turbine on the fly, and then determines which pictures it needs to take in order to get a full coverage inspection for the customer. We upload all that data to the cloud, and from there we have an in-house analysis team that is blade engineers and blade experts that take a look at all of the pictures, and they assess that this is a crack, this is a erosion, this is delamination, how severe is it, and they can make a recommendation as to how you should approach that as a asset owner. What did I miss? Good.
No, that covers, I think, the first part of it,
Yeah.
yeah. Our much longer journey in SkySpecs, we became experts at blades. And then a lot of what we're known for initially is the drone inspecting blades, identifying defects, and deciding what to repair. We then started to learn, once we amassed a lot of that data, and we'd been working with a lot of key customers globally for a long time, that they were starting to run out of budget on fixing their blades. We started to realize we have to tackle the entire problem, which is all major components on turbines. We can't just stop at the blade and try to optimize the wind industry as a whole if we aren't looking at the drivetrain, if we aren't looking at the finances and the performance and everything else that goes into the turbine. And there's always a question like, where do you draw the line? As Tom said in the beginning, it was hard for us to not do everything. We focused very much down to being the best in the world at taking a picture of the tip of a turbine blade. You can't be more specific than that. But then once we became experts at that, we had to kind of re-expand and back out to cover the full problem. In 2020, we started to assess this in the height of COVID. How are we going to do this while we're all working remote? We can't go out and test new things in the field very easily. At the same time, we had built a reputation and a network with a lot of startups in the wind industry that were struggling to fundraise or struggling to grow internationally when they couldn't travel. And we saw an opportunity to start acquiring other small companies that had complementary technology to us and that covered other parts of the turbine. So we did 2 acquisitions in April of 21, a 3rd acquisition of May of 23, and brought on a vibration monitoring company, a financial asset management company, and a SCADA performance management company. Brought all of those together to a more comprehensive asset management solution that we now sell globally as well. That journey, a lot of what we're known for is the robotics and the drones, and that's the part that's out in the world that can be seen and touched and people understand. But at the end of the day, it does get back down to, can we help owners operate their wind farms more efficiently?
Something I want to add to that, I think is probably interesting for some of your viewers, is you brought up this point about where do you draw the line? Because as you said, we were doing blades, and we were doing a pretty good job of it. We became a very well-known name in that sort of niche space very, very quickly. And I would say we faced in probably around 2018 this important question of like, what next? Because it is such a niche industry, blade inspections. It's not enough to sustain growth as a venture capital funded company for long.
Yeah.
So we're faced with this challenge of, do we go to other industries and do we do inspections of other kinds? Maybe we keep it fairly adjacent and we go transmission line inspections in solar because it's similar drone-based stuff for energy companies. And I would say what turned out to be a really good decision for us is that we chose to actually go deeper. And as Danny said, we stuck with these challenges around wind energy asset management. Rather than go horizontal, we saw that our opportunity was to go much, much, much deeper in order to solve the customer problem. It's kind of like a magician pulling one of those ribbons out of the hat. You just kind of keep pulling on that problem and we keep finding more and more that there is for us to solve. So I think that was a good decision. Someday it'll expand.
It certainly has panned out to be a good decision right now to be the experts in this space. We take the approach of partnering with our customers and helping them solve their hard problems. So if they bring another hard problem to us that fits within the scope of our expertise, we like to dive in, actually get our hands dirty. We're not afraid to be in the field working with them and try to apply our variety of technologies and automations to their problem set.
As one of those startup founders, what advice would you give them when they first start their own business? I know that for myself, there are pivots and stuff that we need to change. We spent too much money on R&D, we spent too much on HR or people on the team we had to cut, like during this time when it's really hard to raise a fund. What advice would you give for startups and business owners?
I have a lot of advice over the years, but I'll try to boil it down to a couple of points. First, I think it's really important to focus on the problem you're solving, not the solution. As I already said, once again, we were solution looking for a problem. We were lucky in the sense that we found the right place, the right time. It does take a lot of effort. It's not just pure luck, but we did have the opportunity to evolve enough to find the right opportunity to apply our technology. But a lot of times in 20 other parallel universes, we failed 19 times. It's not the best strategy to start with the solution. Very much focus on the problem. And it will require a tremendous amount of perseverance to get through, especially the early stages, where every other day you go from success to failure to success to failure. You have to push through that in order to succeed long term, which requires that you care about the problem enough to stick with it. So find something you're passionate about, focus on the problem, persevere through it. And then lastly, don't be afraid to just get started. I think too often people sit and wait for the perfect time where they feel like they know enough. That will wait too long. You'll be waiting too long. You have to get started. You won't learn enough until you've actually tried it and figured it out from there. You can't just write it, business plan on paper and stop there.
Yeah, and I think complementary advice to that last point, especially about just doing it. I think it's not that it's a bad idea to plan. It's absolutely a good idea to plan and to put your thoughts to paper. But as Danny mentioned, a lot of people will just sort of get stuck in that moment where you kind of need to take the first step and just make a phone call the customer, find a way to get started. When it comes to actually building things, I think that there's these competing priorities when it comes to being a software engineer. Very common in starting in entrepreneurship, at least from what I've seen, is do I want to build it right or do I want to build it fast? Sometimes it feels like those things are competing. And I think one way you can kind of get around that, my primary piece of advice would be build for learning. So structure the way that you're approaching problems such that you can learn really quickly and you can be iterative. I think that's true. You can apply that same logic to the business model. You can apply that same logic to the code that you write.
Well, build for learning. I like that.
Yeah, structure everything you do so that you can learn quickly and adapt.
The future of SkySpecs, 10 years from now, batteries are getting cheaper, more energy dense, drones are getting better. I know you said you're not too focused on being a drone company, but you guys still have a lot of passion for drones, a lot of that. So where do you think they're going in the future?
Well, it's two different questions. Do you want to know where the business is going or where drones are going?
First where drones are going.
I'd say like all robotics, not just drones. I recently got a tour of the robotics building on North Campus here, which has a tremendous amount of advanced capability and technology there that students are building. Computation is easier. It's easier to access at an earlier age for an affordable price. It's easier to test things and mess them up and test them again than it ever was before. So from a robotics perspective, I think you're going to continuously see them augment tasks, whether they're digital tasks or physical tasks. You'll see them kind of come into every part of life as we move forward. However, I also think that you're not going to like all of a sudden get this amazing battery where everything is possible now. Like battery evolution is slow. Computation evolution is significantly faster, and you'll just deal with power consumption problems. I don't think it's going to unlock anything for really anybody because it's so slow. Instead, find other ways to do it. And not everything needs to be powered by a battery. There are ways for robotics to operate with that constraint in place. So I'm not holding my breath for any sort of battery innovation for us. And even if the battery doubled in capacity, our operations wouldn't change at all. We do one inspection on one battery. If we did 2 inspections on one battery, our economics don't even change. You still have to have someone there to change the battery. You have to take a leap from 1 to 20, where you could then remove the person that's changing the battery. So it's a massive leap forward before it has any impact to our operations. So from that perspective, I'm far more interested in computational advancements. What do you do with the data? How do you make better decisions with less data so you can capture less data and make those same decisions? And I think that's true throughout many areas of robotics and the future of automation in general.
Yeah, I think for me, I totally agree with those sentiments as well. And I would say that the things that are exciting to me about just robotics in general we're only scratching the surface in terms of what AI is going to do for us as it relates to robotics. I think that the way it'll probably play out is that it will become a lot easier to teach or to program a robot to do something new than it was in the past. There used to be at least for us and for when we were first getting started in MAV, every sort of system comes with its own algorithm development, and it's a lot of work to do building an autonomous robot. I think we'll increasingly see things that are a lot more modular. We'll start to see things like the robot operating system and otherwise that make a lot of that a lot easier. And so it's probably an area where we need to do some investigation ourselves. I think the other area that's really exciting to me is unsupervised robotics. So as Danny said, our operation relies on a human that actually takes the drone on site and does some amount of work. That is, at least for now, a limitation of changing batteries. Also the fact that it's not legal in general to fly a drone without someone there to watch. So I think that'll change over the next 10 years. We'll see a lot more drones that are just out there doing work without someone paying attention. And I think that's probably true of other types of robotics as well. So things that are on the ground and otherwise. I think it's a really exciting future for robotics, especially in wind energy and in other energy applications.
When I was in UT Dallas, so I studied there, I've seen those like delivery robots. So they put it's mainly like lunch or meals, they put it in the robot and then it would deliver it to someone to doorstep. That's pretty cool. I remember one of those projects I did, robotic arm, and I believe we used Arduino and stuff. Yeah, that was an Italian company, right? I don't know if you all used it before.
Arduino, sure, yeah.
Yeah, that's what I remembered for now. I know like some of my classmates, they use those ones powered by TI, those were for free, but if we burn that one, then the cost is like 20 or so, yeah.
I'm also very excited. I'm glad you mentioned that because the bar has gotten so much lower in terms of trying things with robots. Like you mentioned Arduino. I think it's really cool to see things like the first robotics programs at high schools and middle schools that I'm seeing like middle schoolers who objectively know more about robotics than I did when I got to college. Clearly, the education system is getting much better as it relates to robotics, and that's pretty exciting too.
Yeah, it's definitely very exciting stuff. You could probably sometimes your core innovation is in the software and the payload designed around the drone, like what you attach onto it and the software behind that. So yeah, it's gonna be great to see more innovation around that space.
Yeah.
But yeah, so your advice for young people, in general, what would you give as advice? Maybe entrepreneurial, maybe personal or education wise.
Sure.
What would be your advice?
Same as the other advice I gave is get started early. Just try stuff. Even as a student, don't be afraid to just try and fail over and over and over. That's how you learn. When I was a student in Michigan, I was an aerospace student. The mistake I made is I felt like I had to take every class that said aero in front of it, and I never tried anything else. I didn't go to the computer science department until grad school. I didn't go to the business school. I didn't ever leave my program to go try other things. In high school, I did not step out of my comfort zone to try programming or robotics or anything like that. All of that came later. Now granted, it's a little harder to find back then. These days, like Tom said, the first robotics, it's pretty ubiquitous. But I'd say for young people, a lot of people make the mistake of thinking, I'm going to get out of high school and then I'll know a certain amount of information. Then I'm going to get out of college and I'll be an expert a little bit more. Then I'll go to grad school, I'll learn a little bit more, and they're constantly striving to feel like they know enough to get started. And I would say you could start these projects in high school and come out of high school with very solid knowledge on a career path in robotics, in any sort of thing to do with programming. That's all available on the internet today. I would just get started. Don't wait to feel like you are an expert on something.
Yeah, kind of related. Mine was going to be have a lot of hobbies, try a lot of things, do things that interest you. It doesn't have to be a path to a career. Just try stuff.
Yeah, ours was accidental.
Right. We got into robots and drones in general by accident, and we got into wind even more by accident.
Yeah.
So here we are. Try things, and maybe find people as well that you jive with, and find a way to do something fun or productive with those people as well. I think that was a big part of the story that we didn't talk too much about with the SkySpecs founding. Is we've got 5 of us that have been working together now for
In the 13th year now.
Yeah,
You and I are doing 15.
13th year of 13th year of
SkySpecs,
and before that 15 years of working on the student project together. So you come to understand how one another are going to act. For better or worse, you come to understand like what each other's skills and strengths are, and I think that's profoundly valuable to come out of certainly the college experience with.
So work with people for a long time, get to know them, and make good connections.
And have lots of hobbies.
And lots of hobbies. And I saw the third employee at SkySpecs. They were from Skunkworks, right? And at Lockheed.
No, he wasn't the third. But yeah, we did poach a former colleague of ours at the university who was at Skunkworks to come back to Michigan and join. He was employee like number 8 or 9, something like that. We don't really keep a close count on the employee head count, but he was certainly early on, and we did convince him to come back to Michigan and help launch our global operations.
Yeah, speaking of people who try a lot of things, right?
Yeah. So I guess Lockheed or Northrop should have probably given you those jobs in the beginning.
Yeah, they should have tried harder on the internship for sure.
Right, and then just moving into our last questions, just for fun. So you said in an interview, this could be outdated. You were playing the game Eclipse, the strategy game, intergalactic board game. Do you guys play that together still?
Since kids were born, it's been a little bit harder, but I would say, I'm an avid strategy board game player, as is my wife, and something that Tom and I bonded over in the early days. I think way back to the first Risk game in Kalamazoo at my parents' house, I think we did once, right. A long time ago. And we certainly, my wife, Tom's wife, we all bonded over strategy board games in the early days. I've always found it as a great way to try different strategies that apply to real life in a very limited, time-bound way. And I think that it's not only fun, and it's a great way to bring a group of people together, but it's a great way to kind of exercise your mind. That's why I love playing them. But yeah, I probably own 100 strategy games that I never have time for anymore, but I hope to again someday.
Yeah, Eclipse is an exceptional game, but it takes
a good
6 hours.
Yeah,
it's a proper day, and I don't think either of us get those that often.
Yeah, it's been a long time since I played.
Well, I want to thank you guys so much for coming in. It's been great. You shared a lot of great insights into starting a business, and I just want to thank you again for coming in.
Absolutely. Thanks for having us.
Appreciate
Appreciate it.
Yeah.